Good afternoon, everyone. So today I'm going to talk about our research entitled Proficiency and External Aids, Impact of Translation Brief and Search Conditions on Post-Editing Quality. First, I want to highlight our study. We chose the source text from ATA certification exams, which is rarely studied in previous studies. And we also use ATA arrow annotation schema because this is a pair. If we use the ATA source text, we want to use the ATA annotation schema. This is the first highlight of our research, and the second highlight is we rarely see post-editing studies. They control the translation brief variables, like they seldom specify they're using full post-editing translation brief or light post-editing translation brief. But in this research, we want to address this difference and how that impacts the translation quality. And the third, we can say, this is the first study we use our new launch tool, Trados to Translate 2 conversion tool. And that's how we collect our data and analyze our data as we talk about it in our introduction part. And the purpose of the study, why we're using Trados to Translate 2, because we want to simulate the authentic work environment of post-editing. In this case, so we want to give the professional CAT environment to the translators with different search conditions. For example, we provide Trados interface with term base, we provide it, or we give the translators the option to do internet search. And the second variable we want to control is we give the translators appropriate different translation briefs. For example, light post-editing or full post-editing. And in that way, we want to see what is the impact on the process and product of post-editing. And we want to emphasize our experimental design because this is like a pilot study with our new research tool. So the first thing I want to say is our participant, because it's a little bit special. We hired 12 participants, and it's in two groups. One group is 5 Chinese student translators. Their L1 is like their first language is simplified Chinese, and their L2 is English. And we also hired 7 Japanese professional translators. Their L1 is Japanese, and their L2 is English. And according to our pre-test survey, most of the Chinese student translators, they fall into inexperienced translators category, and most of our Japanese professional translators, they are experienced translators. And that's our participants. And also our materials is also a little bit special because we use 4 English source texts from ATA certification exams, which is altogether 47 segments with altogether about 1,000 words. That's each text is about 250 words, and we put them all into Google Neural Machine Translation, and we get 4 Chinese Google Neural Machine Translation output and 4 Japanese Google Neural Machine Translation output, and we use this 8 text as the translation memory for our participant to work on to post-edit. And we also choose from the GNMT output to see what has the errors about terminology, and in both English to Japanese and English to Chinese language pairs. And we collect 28 words that already has terminology errors in the GNMT outputs, and we correct it manually, and we generate this term base for all of our participants to use. as a provided term base in Trados interface. And also we controlled, as we said, we controlled two variables. We control the translation brief we provide to our post editors, and also we control the search conditions they can have access to. So for example, we give the translators either light post editing translation brief or full post editing translation brief according to ISO 18587 criteria. And then also for the translators, for each text, we ask them to do either external search with term base we provided them, or they can search by internet search, but without the provided term base we provided. So altogether, they got 4 different translation tasks for each of the tags we provided. That is PLT, which means they need to translate the text with light post editing translation brief and the term base we provide, or the light post editing translation brief with internet search but has no access to the term base we provide, or the full post editing translation brief with the term base we provided. That's we call it the PFT. Or they are provided with full post editing translation brief with internet search option, but cannot have access to the term base. That is a little bit abstract, so I can show you the working interface they're working on when they're doing our experiment. So we provide the term translation memory with the Google Neural Machine Translation output. Yeah, it's on the translation memory TM section on the top of the Trados interface. And also when they click on the target site, each segment they are working on, the translation memory will pop out segment by segment for them to work on. And also, for example, we control the term base or internet search condition. It's illustrated on this red rectangle. So if it's a term base provided, they can see the term if it's a term that occurs in the source text that we provided. And if it's not, if they're under the internet search condition, here the rectangle will be empty. So they don't see anything here. They should only get the resources from the internet search, but without the provided terminology. That's our working participant material control variables. And how can we collect the data? First, we collect their keystroke data by Trados collativity plugin. And second, we collect also their gates data by, for our Chinese participant, we collect the gates data by Toby. For our Japanese participant, we collect it by iLink. And also how to synchronize these 2 streams of data together. We use our new launch research tool Trados to transfer to. And also after all this experiment, we got altogether 658 segments, and we hired 2 professional translators, 1 Chinese and 1 Japanese, to annotate the translation output according to ATA adapted error annotation schema. According to the ATA error annotation schema, the most frequently occurred error types are the 6 I listed here: mistranslation, terminology, omission, addition, usage, grammar, and other. And we, according to our research goal, we just merge the first 3, mistranslation, terminology, omission, and addition, to accuracy error. And we also merge the usage, grammar, and other into fluency error. And we count the error occurrences by segment. And also according to the severity of the error, the annotators annotate this error further as critical error or minor error. So altogether, we get four kinds of error types: accuracy critical error, accuracy minor error, fluency critical error, and fluency minor error. And we aggregate all the error occurrences by either it's the Google Neural Machine output or the post-editing output. And we see there is a similar pattern of error occurrences compare GNMT to PEMT. We see that most frequently occurred error type is fluency minor error, followed by accuracy minor error, and followed by accuracy critical error, followed by accuracy minor error, and the fluency critical error. But if we compare the two distributions, we can see after post-editing, there are decreases in almost all kinds of errors. For example, fluency minor errors decreased from 50% to 46%, and accuracy minor errors decreased from 18% to 17%, and the fluency critical error decreased from 7% to 4%. And we joining the Japanese and Chinese participants' translation output together to see the error distributions across the four tasks we controlled. And then we can see that for example, if you look at the green rectangular here, we can see that if the translator is given the translation brief of full post-editing with internet search, it leads to the least fluency critical error. And whereas if the translator is provided with light post-editing translation brief with term-based provided, they tend to produce the most fluency critical error. And also, if you look at the red arrow on the top of this figure, you can see that if the translator is provided with full post-editing translation brief with provided term base, they tend to produce the least fluency minor error. Whereas if they are working on light post-editing with provided term base, they produce most most fluency minor error. And also, if they are provided with light post-editing with search or full post-editing with terminology, they tend to produce more errors than other two tasks. That is from our different tasks. We can see that overall, if you are provided full post-editing translation brief, you tend to produce less errors altogether overall than light post-editing translation brief. And we see that this is for joining the different kinds of participant. If we look into our two groups of translators, we see there is very much a different tendency between them, as we see from the left, from the figure on the left side. The blue lines is Chinese participant, and the red lines is Japanese translators. If we put, we did a mixed two-way ANOVA, and this is the visualization of this analysis. And our dependent variable is accuracy error occurrences. And the first independent variable is translation brief, and that's what we controlled for one condition. And the second independent variable is search condition. And we see that we can see first the overall Japanese participants tend to produce less accuracy errors than Chinese participants. And then if we see from the different tasks, we can see that Japanese translators, they don't have significant difference between the four texts. But for Chinese people, we can see that for Chinese participants in our study, we can see that if they are provided with term-based, they tend to produce less errors than when they are provided with internet search. This is quite surprising because we think if you are provided with expanded search options, you can do maybe better quality performance. But for our Chinese translators, we don't see that. We see that when they're provided a term base with only 28 words, they produce less errors than they're provided with whole internet search. And second, we see like if the dependent variable is fluency error and the independent variable is translation brief and search condition, we see that Japanese participants, they have a gradual decrease across the task about the fluency error, but the Chinese participant doesn't have a lot of significant difference between each task. And we would see that from light post editing towards full post editing, the Japanese participant, they have a very significant decrease in fluency errors. That leads to our conclusion. First, first is like overall, if the translators are provided with full post editing translation brief, they tend to produce less errors than light post editing translation brief. And for experienced translator, as illustrated by our Japanese translators, they are more sensitive or they understand more of our translation brief, so they produce less fluency errors when they're providing full post-editing translation brief. And for our inexperienced translators, as illustrated by our Chinese participants, when they are provided with term-based, they tend to produce less accuracy errors. We kind of summarize this as the difference between their translation proficiency, as the Chinese versus Japanese participants, they produce more accuracy and critical errors. This is quite expected because the Japanese translators are more experienced. They constantly deliver higher quality translations than Chinese participants. And also we kind of conclude that the inexperienced translators, they have less research skills, and that's why when they are provided with term-based, they tend to provide higher quality. And the experienced translators, because they have better understanding of the translation briefs, so when they are provided with the full post-editing translation brief, they tend to produce less fluency errors rather than light post editing. And because of the restrictions of the availability of the participants of certain language pairs, we only got 12 participants in our study, Japanese and Chinese together, but we put our data set public available in TPRDB. All of you can replicate our studies and look into our data further. And this is the ATA-ZH22 is for Chinese participants, and the ATJ-A22 is for Japanese participants. And we are also planning to expand this study. And here are our references, and thank you for your attention.
Thank you, Longhui. And now we are ready to receive questions or comments.
Thank you very much. I found your presentation very interesting. Out of curiosity, because I also analyzed errors in my study.
Yes.
How did you count the number of errors in your study?
So we count the error occurrences according to the 4 error labels I just mentioned, and then we aggregate it by segment.
So for example, what if there is a fluency error within an accuracy error? Those are 2 different, like there are 2 different types of errors, right?
Usually it's we ask the annotators to work on alignment groups. So we first manual align it segment by segment, token by token, and then we annotate the translation errors according to alignment groups. So if you decide this alignment group is fluency errors, it cannot be accuracy errors. So it's like more prominent, more dominant errors.
Okay.
Yeah.
So what if a participant, for example, mistranslated the whole sentence?
Yeah, still we annotate token alignment group by alignment group, and we count the total error numbers.
So that would be the number of alignment groups inside of that sentence?
Yes.
Okay.
But we count by words.
Okay. So in your annotation schema, error annotation schema, how would the different severity levels play in?
Yeah, so we have, it's here, right? We have 4, where is it? Sorry, here. So we have 4 labels, but we first annotate according to this.
Right.
And then we annotate by critical minor, and then we group them together as 4 labels.
Okay, but when
we annotate, we use mistranslation, critical, mistranslation, minor, terminology critical, terminology minor, like this.
Okay.
Yeah.
And when you analyze the data,
yeah, we group it into 4 labels.
Okay.
Yeah. Because it's easier to understand. If we annotate, we annotate it as this, like 10 different types of errors. But when we analyze the data, if it's like 10 sub translation errors, it's hard to understand our result. So we aggregate according to these 4 labels.
Okay.
Yeah.
Thank you.
Thank you.
Okay, it seems that we don't have questions online, so thank you, Longhui, one more time.
Thank you.